Hello guys, I'm Sandip. I'm a physics faculty at IIT-JEE, and today we are going to start a brand new chapter which is related to motion, or we can say mechanics. What is mechanics? Mechanics is, we can say, is a branch of physics which actually deals with this all the motions of the bodies, right? Motions of the body means what? Right? So consider, right? So this is our chapter. So first of all, tell me what is the motion of the body, right? So our chapter's name is motion and time. So when I say when I'm walking, or let's say I'm running, right? Or riding bike, or driving car, in the aeroplane, obviously not driving the aeroplane, right? In the aeroplane, you can obviously, you're not pilot for that. So can I say these are all the motions, right? And the time, you obviously know what is time, right? So time is nothing when our class started, when our class ended. So all those things we are measuring it into the time. So most time is not a very big concept, very difficult concept for us, right? So motion, as I said, there are different types of motions, right? So when I say walking, running, driving car, riding bike, in aeroplane, or in any other, you can say in ship, right? In boat, or on horse, you can say horse riding. Everything is motion, right? Okay. So let me ask you one simple question. Now you are sitting in your home, most probably in front of laptop or mobile, right? Yes. You're watching the session in front of laptop or mobile. Tell me, right? My question is, are you in a motion or not? Right? Again, listen to question very carefully. I'm saying, are you in motion or not? Obviously not, right? We can say now we are not moving anywhere, we are not going anywhere, right? So obviously we are at rest. No, I'm saying that answer is wrong. Right? Why wrong? Yes, obviously you will think so. What you're saying, we are obviously at rest, we are not going anywhere. Why we are wrong? Right? Because whenever we are doing the calculations right now, we are considering one frame of reference. Frame of reference means what? Very important concept, which we are going to require for almost 12th, right? Or JEE NEET entrance exams you're going to study. So frame of reference means what? Whenever we say that we are in motion, right? The very important thing to notice is where is the observer, right? So who can say you are at rest? Yes, your parents can say you are at rest. Your brother, sister can say yes, they are watching you, and yes, you are at rest. But tell me, now we know that humans can go to the Mars and moon, etc. Right? Now assume that your brother goes to the moon and by the telescope he watches you now. Can he say that you are at rest? No, obviously not. Why? Because Earth is rotating, right? Earth is moving. If the Earth is moving, obviously you are also moving. Very simple. Okay. So this motion means what? Motion, we can say it is a relative concept. It is a relative concept. Means it depends on the observer, where the observer is. Only the observer can tell whether you are in rest or in motion. And it is also possible that at the same time, for one of the observer, you are at rest. Right? So observer on the earth, we can say yes, you are at rest. But observer on the moon, he will say no, you are in motion. Right? Which one is right? Yes, both are right. No one is wrong there. So what is the concept here? That frame of reference means the where is the observer is very important thing for this motion. Okay. So this is about the motion and the frame of reference, obviously. And now let's talk about the different types of motions. Right. So 4 types of motions we already know that when we are walking in straight line, right? Obviously, right? Then riding bike, etc., etc. Those are all along the straight line. We are only walking on the road, right? We are not flying upward. Right? So can I say those examples of the motion are the motion in straight line? Only one straight line. Okay. Now let's take another example. Considering merry-go-round, right? You must have enjoy the rides on the merry-go-round, right? Okay, there are different fun centers, right? Imagica, etc., etc. So there we do enjoy the merry-go-round. So what are those? Are we going into the straight line? No, we are moving in a circle, right? It could be a horizontal circle or it could be a vertical circle, like this also, right? So it depends. So that motion is not straight line motion. Tell me the path of that motion. Can I say it is circular? That's good. So we can say that is a circular motion. Simple. What are the different types of other types of motion can you imagine? Right? Try to think on that and tell me, think on that. What are the different types of motion? We already know about the straight line motion is also there. Circular motion is also there. Right? Okay. So do one thing today, out of curiosity, not for our examination. You don't have that straight line, different motion right now. You don't have to study that, but out of curiosity, just search on that. What are the different types of motion there could be? Right? Even on the screen, also on this image, also you can see that car is moving somewhere. Rocket is going upward. So upward motion will be there, downward motion, horizontal motion. Many motions are there, right? Also, if you look closely, there is some pendulum type thing is there, right? That is also moving. So it also has some motion. So a lot of types of motions are there. So do one thing today. Try to find out how many different types of motions are there. Okay. Sure. So today, what we are going to cover. So first of all, distance and displacement. What are the distances and displacement? We already know what is the distance. Right? We will see what is the displacement here, right? Then speed, velocity, when we are riding the bike, right? So normally we are riding the bike with some particular speed, right? We cannot, we know that we should not ride the bike very fast, right? So why not? Obviously, we don't need the accidents. How much should be the speed? And how much should be the velocity? So what is the actual difference between speed and velocity? We can say that also we are going to see it here. Then acceleration, you can say what is acceleration anyway, right? For the bike also there is one handle have the acceleration, right? Yes, can anybody guess what that accelerator do? Right, accelerator increases the speed. Very simple. So can I say acceleration is the one who is actually responsible for increasing the speed, right? Even in the car also there is one accelerator, not at the handle or steering we can say, but at the pedal we can say. Right? So there is a brake, there is accelerator, there is one more thing, clutch. We don't worry about the clutch now. But acceleration, accelerator and brake. Accelerator is going to do what? Increase the speed. Right? What is the brake doing? Brake is decreasing the speed. Very simple. Okay. So can I say acceleration is the one who is increasing the speed and brake is decreasing the speed? Okay. Even the brake is also called as acceleration, right? But we can say it is a negative acceleration. Negative acceleration means it is affecting in negative way, right? Means it is decreasing the speed, we can say. So all these topics we are going to see this today, and we'll also solve some numericals on that. Okay, so this image you can see here, yeah, this image is something of map, right? Nowadays we do use the Google Maps to go anywhere, and we don't have to ask directions to anywhere. Just put the whatever the to go, and Google Map will take us there, right? Very simple technology, very nice technology, right? Nowadays we can use even today. Okay, so let's see. So first, rest and motion depends on observer. I used one more term here. Remember that term, right? Frame of reference. Frame of reference means where is the observer? Where is the observer? So observer is on Earth or observer is Moon. Similarly, we don't have to go to Earth and Moon. We can consider very normal situations. Consider a train. Consider a train is moving. A train is a very best example for these things, rest and motion. Train is moving. You are in the train. Consider you are sitting in the train. Right? Tell me, do we say that, right? Trees are going back. We know the trees are not moving anywhere. Trees are going back. Why will you say that? Right? Or station goes back. Why? Station is not going anywhere. What you are going forward, right? In the train. Still you say yes, station went back. Right? Because you are the frame of reference, or train is the frame of reference. You are the observer, we can say. Right? So though the station is not moving anywhere, station is not going anywhere, station is at rest. But according to you, according to train, according to the frame of reference of the train, what we are going to say? Yes, station is going back. Simple thing. So this is the frame of reference. So same thing you can see. So if the observer on the ground is here, consider another observer, another frame of reference, right? So what you can see, yes, train is moving away. Simple thing, right? What you can see, this observer is going back, right? So this is actually the concept of the frame of reference, and therefore we are going to say rest and motion depends on the observer, right? Where is the observer? What is the frame of reference of the observer? Okay, so next, now let's talk about the distance and displacement. Okay, so now take example that you're going to school, right? So when you go to school, let's say this is your home here, right? Everybody likes to go to school, right? No? Yes. So this is the school, and let's say this is your school building, this is your home, and the distance between those two is, let's say, 2 kilometers. So in the morning you are going to the school, right? And after the school is over, you again come back to your home. So tell me how much distance you are traveling. Let's say you have the bicycle, right? On the bicycle you are going to school from your home. How much distance you have traveled? Right? There is 2 kilometers you went to the school, 2 kilometers you came back. So total distance is 4 kilometers. Simple. It's very easy to understand, right? Now, distance is very good. That is total distance we can say, or the other name is for that is total path length. Okay. Okay. Even let's measure the distance for this girl. She's moving from where? She's starting from A. She went to B. So let's say 100 meter, and again come back here up to 50. So total distance, how much she covered? Right? She covered 150 meter. Similarly, you covered how much? 4 kilometer, right? You went to school, came back. Okay. So this is very simple to understand. Now let's talk about the displacement. So what is displacement? Displacement is the shortest distance between initial and final point. Right? So what is the meaning of that shortest distance? So consider, let's our example. In our example, we have already seen that you have traveled 4 kilometers. But obviously, where you started at this home, your home. Consider this is our initial point, right? You go to school and came back. So what is the final point? Again home. And I say again you reach at home. So final point is also home. Initial point is also home, right? So simple thing, displacement is what? Initial and final position. In this case, initial and final position are same. So what is the displacement? 0. So what I can say, your displacement in this case is 0 kilometer. Remember. So yes, obviously you have traveled 4 kilometer on your bicycle. Still what we are saying, you haven't traveled anything, right? Rather, your displacement is 0. Displacement is 0 means you didn't went anywhere. You came back to your original point. Okay. So displacement only represents where you started and where you went. That is the only thing, right? Displacement is same. Okay. Similarly, this girl's position, let's consider she went 100 meter and again coming back up to point C. Okay. So displacement says, I don't care where that girl went. She went to B or D or doesn't matter anything. Consider she went to the D point, then this E point, then F B point, and again came back to C point. Displacement says, I don't care. Okay. So it says just find out the where is A where is C, and measure the distance between them. Right. So whatever, this is our initial point, this is our final point, and the difference between or distance between that point is normal our, let's say 50 meter. So displacement of girl is how much? 50 meter. Similarly, in your case also, displacement, what displacement says? Displacement said I doesn't care whether you go to school or you go to garden or anywhere, or okay. So go anywhere, doesn't matter. But it says, tell me where is the initial point and final point. If you got the initial and final, those are home. So your displacement is 0. Doesn't matter how much you have actually traveled. You went to any shop or coffee shop to have coffee, or ice cream shop to have ice cream. Hotel, doesn't matter. You started initially at home, you went finally at home. That's it. Simple. So this is the distance or total path length, or displacement, not distance actually. So distance is what? Distance is, yes, tell me how much distance you have traveled, right? And displacement doesn't care anything about that. Okay. So this is the initial final point. Why they are saying the shortest distance? This is also important thing. Why they are saying the shortest distance, right? So for that, let's take one example. Now, instead of this straight line, consider if this is the some rectangular ground, we can say, right? Or consider this is your home, right? This is home. This is your school, obviously. Those are in straight line, and we know that, right? Then consider there is some ice cream shop is here. There is ice cream shop, right? And here, let's say coffee shop. Now consider, okay, this is 2 kilometer, this is also 2 kilometer, this is also 2 kilometer, everything is 2 kilometer. Can I say it is a square? Yes, it is a square. So you started from the, let's say, home, and first of all you go to the school, right? After school ended, let's say, or instead of school directly, let's go the coffee shop, or school, yeah, coffee shop. So directly went to the school, coffee shop. So this is a point. Now our motion, we are only considering this much of the motion. Afterwards you will go to the school, from school you will go to the ice cream shop, then home. We don't care about that, right? So consider this is your initial point, this is your final point, this point is C, and now they are asking us to calculate what is the distance and displacement. So this is the road, obviously you cannot go in between, right? So what you will do, you will go from here first and then you will reach here, right? Very simple. This is not the road. Okay. So how much distance you have covered in this case? This is the distance or total path length. 2 plus 2 kilometer. Can I say again 4 kilometer? So again you travel the distance 4 kilometer. But what is the displacement? Right? Initial final point. And now we are going to see what is the shortest distance. Shortest distance means again displacement doesn't care whether there is a road or not. This is the initial point, final point. Displacement says join these two and find out what is the distance of that. If this is 2 kilometer, this is 2 kilometer, right? Then displacement says this AC, this yellow color line will represent the displacement. Obviously, we have to use some geometry there, right? You must have learned the Pythagoras theorem. In that Pythagoras theorem, you can calculate something like this, right? So consider this is our B point. So I can say AC square is equal to AB square plus BC square, right? So I can say this is 2 square plus 2 square, or this will become 8, or final answer is 2 root 2, right? 2 root 2 kilometer. 2 into square root of 2 kilometers. That is the displacement actually. Okay. So this is the difference between distance and displacement. Okay. So now consider, let's find this is the one animation, simple animation there. Right? So this is the starting point. They are saying consider this is the starting point, and we want to calculate distance. Distance means what? Whatever distance you are traveled, right? So along this path you are going. So we have to calculate all the distance, 10 kilometer, 10, 10, 10, 15, 10, 5. Add all these, you will get the 70 kilometer, right? And about the displacement, what will be the displacement? So how to calculate the displacement? We all know that displacement is what? It is the shortest point between what? Initial and final point. So consider if this is your initial point, which one is the final point? Can I say this is the final point? Here it is going to stop. So initial point, final point. So this distance, right? So this will be your distance, obviously. This is your displacement, not distance. Displacement. If that is a 14 kilometer, they have written here. The 14 kilometer will be displacement. Okay. So very simple to understand. Okay. So now take one example on that, right? Let's try to solve one example. Right. So consider in your school there must be a ground, right? Circular ground, let's say. Tell me if you start from one point, let's say here, you started from one point, A point, and for jogging, right? For running on the ground, running on the track. Now tell me if this radius is given as, let's take radius as 2 or 10, let's say 10. 10 is your radius. Okay, 10 meter. So 10 meter is the radius, and you want to move onto that. 10 meter will be very less. Let's take it as it's 100 meter. So 100 meter is the radius. Okay. And you started from the A point, and let's say you covered the half circle. Let's say at B point, right? So you only run for the half of the circle. And now I want you to calculate the distance as well as displacement. So distance is how much? Let's talk about the distance first. Distance will be whatever distance you are. How much distance? Obviously, you were running on this circumference, right? So I think you know what is the formula for this circumference. So you can see, even though in the physics we need the concepts of the math also, right? Yes, maths is also very important for our physics lecture. So I know if the whole circle is covered or circumference of the whole circle. Circumference is how much? Circumference is 2 pi r. But we have only covered half distance. So can I say half into 2 pi r, or 2 will get cancelled, pi into r. This is how much? 3.14 we can say, right? Into r equal to 314 meter. So this is the distance you covered, right? Okay. Then let's calculate the displacement. What is the displacement? I know that displacement is the shortest point between shortest distance between initial and final. Which one is the initial point? A. What is the final point? B. Right? So what is the shortest distance? Shortest distance, can I say this will be the shortest distance? Yes. How much it is? Can I say it is equal to diameter? That's right. So that is 2 into r, or 2 into 100, or displacement will be, I can say, 200 meter. Okay, so this is the question they could ask you in the exam also, right? So remember how to solve this type of questions. Now this is the question for the half circle. Okay? So if you cover half circle, now I want you guys to solve for the full circle. If you complete one round, what will be the distance and displacement, right? Okay, so you have to solve these two things at home. Okay, good. So now then remember, between these two, distance and displacement. Okay. Remember one more thing. Consider this is your home, and you goes to the school, obviously, or away, right? 2 kilometers. And now consider ice cream shop is here. Here is the ice cream shop. Okay, at 1 kilometer. If you started from the home, goes to the school and come back to home, we know the distance covered is 4 kilometers and displacement is 0. That's very good. Okay. Now tell me, from home. You started from home, goes to school, school to home, and home to now ice cream shop. Right. So what is the total distance covered? Total distance covered will be 2. You went 2 kilometer, 2 back, and 1. That will be 5 kilometer, right? What will be the total displacement? This is the important thing now. Right. So displacement will be like consider this is our origin point, we can say, or initial point, right? Let's say this is initial point. This is our final point. Okay. So now the final point, this is our reference point, I can say. Home is our reference. So final point is beyond or behind the reference point, initial point. So if this direction is taken as positive, you know the positive x direction and negative x direction, right? So can I say ice cream shop is in negative direction? Yes. So final minus initial, I can say that it will be a -1 kilometer. Right. So very important to notice one point here, that displacement could be negative. Displacement could also be positive. We know that we have seen in this coffee shops example that displacement was positive, obviously 2√2. Or even in this girl's example, that displacement was 15. Displacement could also be 0 when you come back to your initial point as you go to school and home, back home. And displacement could also be negative. Simple. But distance, remember, distance is always positive. It could never be negative. Okay. So they could also ask you the small difference between distance and displacement. What points you can write for the distance and displacement? That distance is the actual distance covered. Displacement is the what? The shortest distance between initial point and final point. Then distance will be positive. Displacement will be could be 0, could be positive, could be negative. Right. So these are some points you can write. Okay. Then you should also be able to solve this type of questions, numerical questions, okay, on distance and displacement. Okay. So now this is one question. Let's try to solve this. A runner travels around a rectangular track with length 50 meter and width 20 meter. Right. So this is the rectangular path. He travels from A point. After travels around track 2 times, runner come back to starting point, right? So in the previous slide, we have taken the circular ground, right? Now this is a rectangular ground, and your runner is traveling like this. Determine the distance and displacement. So tell me, 1 round means how much distance? Can I say perimeter? Similar to our circles, it was circumference. Now it is perimeter. Let's calculate this: 50, 20, and 50, 20. Right? So it is perimeter of the circle, right? So perimeter of, not circle, rectangle, right? So it will become 50 plus 50 plus 20 plus 20. Let's do the quick calculation. It will be 140 meters, right? What for the 2 rounds? 2 rounds mean 2 times perimeter. So can I say 2 into 140? So it will be 280 meter. So how much he traveled? He traveled 280 meters. Very simple to understand, right? Now this will be our actual distance. So 2 rounds is distance. What about displacement? Displacement is what? Displacement is shortest distance between initial point and final point. He started at A, and after 2 rounds, he came back to same point. Right? So what will be the displacement? 0, right? He came back to same point, so displacement will be 0. Very simple. Okay. So now let's move. So there's a concept of displacement and distance. Now let's talk about the speed and velocity we are going to talk about, right? So you can see some terms here. Instantaneous speed is there, average speed is there, average speed, average velocity. Those things we are going to see, right? So let's talk about this speed first, right? Very simple to understand. On our bike as well as in our car, we can say there is speedometer. It shows us how much is the speed. Simple. So normally we ride the bike at what? 50 kilometer per hour, right? Or 60 kilometer per hour. Some people also travel 80 kilometer per hour, right? Those are very fast. We can say should not go up to that much, right? 40 to 60 kilometer per hour is good speed. We can say safe speed, right? So what is the speed? Speed is the whatever they we can see on that speedometer, right? It is in the front of the bike, we can say. Then what is instantaneous speed? Now, when you start the bike or the car from the home, obviously, it's not like you are going with the same speed, 40. That's indicator is only showing 40. Even you can see in this animation too, right? What is happening in this animation? Okay. So let's see. You can see that indicator is changing the its value. It's sometimes it was 20 or 23, right? Sometimes 24, 25, like that. So instantaneous means what? At exact moment, whatever moment you want to find, right? That is called as instantaneous, right? Obviously, it will vary at every second, right? Time is also important, right? So for particular second, this is 17. So at this particular point, how much? 17. Here you can see now it is completely, it has stopped now. We can say it is 0. When it reaches here, it was exactly 23 or something, right? So that is the case of the instantaneous speed. Okay. So it is the speed at that particular second, we can say, which is represented by the speedometer of the car. Okay. So this is instantaneous speed. Now let's talk about the average speed. So average speed means what? Now you can see this car is moving. Distance in the miles is given. Miles is also another unit of the distance, right? So what is the total distance? 5. Car is moving with the uniform velocity? No. You can see car is stopping somewhere here, then again moving, etc. So you can see the clock. Clock is also measuring the time when the car has stopped there, right? So simple, what we can say, this is 0.2 hours, total 0.20 hours. So first of all, let's see, 1 hour is how much? 60 minutes, right? So how much is the 0.20 hours? Let's multiply this 0.25, so I can say 12 minutes, right? So this is the 12 minutes. So consider the car started from t is equal to 0. Car reached it here and the t is equal to 12 minutes. It covered the total distance of 5 miles. So simple formula for the average speed is the distance covered, or let's say total distance upon total time taken. So total distance is 5 miles. Time taken is 12 minutes. Okay. So this is the average speed. Average speed, again, average speed, don't care how much time you in the car was stopped, right? Now consider instead car stopped at, let's say, our ice cream shop. You want to eat the ice cream, right? Car stopped at ice cream shop here like that. Or let's say another 30 minutes, half an hour, the car stopped here. So if you started at t is equal to 0, where you will reach? Total time taken was 12, but you stopped for 30 minutes too. Total time become 42. Right? So if you stop for 30 minutes, average speed doesn't care. Average speed only sees what is the time taken. The car reaches at 42 meter after 44 minutes. Right? So average speed says that this is the total distance 5 miles. And the total time taken is 42 minutes. So average speed say that your speed is very low, right? You are taking a lot of time to come to the 5 miles. Right? So this is the concept of the average speed. Okay. Now, average speed and average velocity. These two things we are going to talk about. Right? So what is speed and velocity? So we already know what is distance and displacement. What is distance and distance is a scalar quantity, remember. Displacement is a vector quantity. Vector means what? Direction is also important. Right? So in case of distance, we just calculated how much you actually traveled. Displacement means what? Where you actually traveled. Right? You come to school and you came back to the home. So you change the direction, right? That is important in the displacement. Okay. Similarly, speed is a scalar quantity, velocity is a vector quantity. We already have seen the formula for speed. Average speed is equal to what? Distance upon time. Similarly, average velocity will be what? This is displacement upon time. So now it's become very easy once we know the formula. We already know how to calculate distance and displacement, right? Let's take our basic example. You started from home, goes to school for 2 kilometers. School is 2 kilometers away. Consider you take the, let's say, 30 minutes to reach there, right? Or let's say 15 minutes. You reach there in 15 minutes. Okay, let's calculate the average speed first. Average speed will be how much? 2 kilometers divided by 15 minutes. So we can say this is our average speed. Simple. What is the displacement? Displacement, you are going from home to school, right? So this is initial point, final point. So I can say yes, displacement is also same. Time is also same, right? Good. So this is the first case we can. Now, in second, you came back after your school is over, you came back to your home. Now we know how much is the total distance, right? So total distance upon total time. In second case, total, we want to find out, this is initial point. You travel total 4 kilometers. Again, you take the, let's say, 15 minutes to come back. So total how much minutes? 30 minutes. So this will be the distance. This is the second path, right? So this is home to school only. Home to school. I can also write it here. Home to school. Now this is home to back home. Second is home to back home. So we started from home, we came back to home, right? So total distance is 4 kilometers, total time taken is 30 minutes. Let's talk about the displacement upon time. In second case, again, the formula is same, displacement upon time, right? How much is the displacement? 4 kilometers. How much is the time taken? Displacement. Okay, displacement is not 4 kilometers. Right, I've done some mistake there. Actually, it's mistake. What is the displacement? It is not 4 kilometers. Right. So in second case, when the motion is from home to home, what we can say that initial point is also home, final point is also home. So displacement will be how much? 0 by 30 minutes. That is 0 by anything is how much? 0. So what we can say when we come back from home to home, in second case, average velocity is 0, right? And in first case, average speed is, yes, there is some average speed. Average speed is not 0, but average velocity is 0. Why? Because displacement is 0. Right? Like that. So very simple to understand. So let's move next. Okay, so let's try to solve this question. Car covers 30 kilometers at uniform speed of 30 kilometers per hour. What should be its speed for the next 90 kilometers if the average speed of entire journey is 60 kilometers per hour? So now consider. First, car started from here, right? And how much it traveled? It traveled 30 kilometers. Let's show 30 kilometers like this only. Car reaches at this point. Okay. After that, car wants to go how much? 90 kilometers. So this is 90 kilometers. This is the second point. Okay. What is the speed here? Speed here was 30 kilometers per hour. Here, speed was, we don't know the speed. We want to calculate speed. Let's call this as V only, right? We want to calculate V. Or let's say V2. V2 is question mark. And this is the total journey. Tell me, what is the total distance of this journey? Or before that, okay, total journey is 30 plus 90. Can I say it is 120 kilometers? Let's say this is A point, this is our B point, this is our C point. Let's find out what is the time taken. Let's say this is V1, this is T1. For here, similarly, time taken will be how much? Okay, so if I consider the total journey from A to C, let's talk about from A to C. They are saying the average speed for the entire journey should be how much? 60 kilometer per hour. So average speed, I know the formula. Average speed's formula, that is distance, right? Distance upon what? Time. I also know the total distance. Total distance is how much? 120 kilometer. Time. Now time, for time, remember, obviously, we need some time from A to B, let's call it at T2. T1. For second, B to C, let's call it as T2. So can I say time, total time will be T1 plus T2? That's right. Is equal to how much? 60 kilometer per hour. They have told us that average velocity should be 60 kilometer per hour. Okay, so let's do simple calculation here. T1 plus T2, I can say this becomes 120 divided by 60, or T1 plus T2 will become 2. And you know the unit, right? Unit is hour. Why? Because time has the hour unit here. Okay, so we got T1 plus T2 is equal to 2 hours. So whole journey should be covered in 2 hours. Then only we will get the 60 kilometer per hour speed. Okay, so we know how to calculate T1. T1 we can calculate if you know the average speed is equal to distance upon time. Can I say time is equal to distance upon average speed? Same thing, right? So let's say this is distance upon average speed. So how much is the distance? Distance in the first case was 30 divided by 30 is equal to 1 hour. So I got T1 as 1 hour. Let's substitute that here in our equation, right? So what I can say, 1 plus T2 is equal to how much? 2 hours. So how much is T2? 2 minus 1. 2 minus 1 is how much? Again 1. So we got the T2. T2 is equal to 1 hour. Let me write it here, right? This is, I got this answer as 1 hour. Okay. We calculated this. Now let's use the different color. So this is the answer we got for T2. Still our problem is not over. What they are asking us, what will be the V2? How to calculate V2? I got the T2's formula. Can I write a similar formula as this one? T2 is equal to what? Distance upon what? Distance upon average speed. Let me use it here. So T2 is equal to distance upon average speed. T2 is how much? 1 hour is equal to distance. I know the distance 90 divided by average speed. Simple. So let's take average speed to the LHS is equal to 90 divided by, let's take this 1 hour to the denominator. So what will be the speed? 90 kilometer per hour. So this is our final answer. We got this final answer as 90 kilometer per hour. Okay. So remember this one, whenever you got this type of equation or in entire physics, try to draw the diagrams. Diagrams will make the concepts very easy. Right. So whatever question is there, what I did, I drawn the diagram there, and then it becomes very easy now. Okay. So this is the you can say difference between speed and average speed. This is how we can calculate the average speed, and we also know the average velocity, right? Average velocity can we how to calculate? Let's consider now this car. Let's take another example here. So this car started from A, right? This is 30 kilometer. And again, it goes to point B, which is at 90 kilometer. So this is B point, and this is our C point, right? And car is coming back. Car came back at point, let's say D. And we want to calculate average velocity now. So average velocity means what? Now we already know that it took how much? Total 2 hours up to this point, right? Now consider it again take 1 hour here. And we want to calculate, let's say, average speed. So average velocity, not speed. Average velocity, we know it is nothing but displacement upon time. So displacement, which is what? Initial and final point. Take those 2 points, find the shortest distance. Shortest distance from A to B. A is initial, B is final. What is the shortest distance? 30 kilometer divided by what is the total time taken? Total time taken is, it took 2 hours to reach at point C. One more, that is 3 hours. So average velocity will become 10 kilometer per hour. Right? So remember, this is the difference between average velocity and average speed. Okay. Now let's move to the next point: average acceleration and average. Okay, average acceleration only. You don't need it 2 times. Okay. So let's say only average acceleration. So what is the difference between this? This is the cool diagram, right? We already talked. If you want to increase the speed, you need some accelerator on the bike as well as car, right? Okay. So first guy is going with the constant velocity. So consider your bike is going with the 40 kilometer per hour, right? You're not using accelerator in that case. But when you're using the accelerator, look at the second guy. He started late, but his speed was increasing. It was not constant. He was increasing the speed. And obviously, you can closely look that even if the second guy started late, they both reach almost at the same time. Right? Why? Because he has a constant velocity. He didn't increase the speed. His speed was, let's say, 10 meter per second always. His speed was from 10 to 20, 30, 40, 50, 60. Right? So he was increasing the speed. This is the condition for average acceleration. And we can use a very simple formula there. Average acceleration is equal to average, or you can simply write the velocity. Velocity or change in velocity. Let's say change in velocity. Changing velocity on time. Okay, so let's also take one example here. Consider on your bicycle. This is your bicycle, right? So this is your bicycle, and you started the bicycle, right? Let's say you want to go to school. Obviously, you started the bicycle. And initially, your speed is how much? 0, right? When you will start the bike, so what you start to do, you pedal the bicycle very fast, then it is going to increase, right? Consider after some time your speed becomes, let's say, v is equal to 10. So this is 0, this is 10 meter per second square, or 10 meter per second. Okay, and consider up to this speed you take almost, let's take it better than 40 meter per second. Okay, if you not 40 will be very large, let's take only 20. Okay, so velocity becomes 20 meter per second, and it take, let's say, almost 10 seconds for this one, of u to 20 seconds. So how I can write the average acceleration? Average acceleration means what? Change in velocity upon time, or I can say, let's say v2 minus v1 upon time. v2 means what? Final velocity. This is 20. Initial velocity was 0. Can I say this is 20 minus 0 and divided by time? So it will become 2 meter per second square. Right? So this is how you can actually calculate the average acceleration using the velocities. Okay. Now let's take one more example of a bike. Now bike has the accelerator. We know that part, right? Now this is bike, and this bike initially, let's start. Consider it's not necessary that your bike should start from the 0, right? Obviously, it starts from the 0, but consider you give some accelerator, and the initial velocity is now, let's say, 20 kilometer per hour. And you started by, and after reaching at some particular point, right? So let's say now the bike speed is 100 kilometer per hour. Let's say it takes you only 5 seconds to reach there, or right? So how to solve this type of question? Again, acceleration is what? Change in velocity. So initial velocity, or v2 minus v1, I can say, right? So let's call this as v2. Let's call this as v1 upon time. So v2 is how much? 100 minus 20 divided by, can I say, 5 seconds? So this, now consider this time has some unit in velocity, right? There is our unit and here is second unit. Something doesn't match up right there. So we cannot just solve this one, right? So what we have to do, we have to convert this into hours, right? So how to convert this? I know 1 hour is equal to 60 minutes, or I can say 60 into 60 seconds. right? So can I say 1 second is equal to 1 by 60 into 60 hours? That's right. Or 5 seconds is equal to how much? 5 into 1 by 60 into 60 hours. So now, yes, now it is an appropriate unit. Or I can also do some calculation here and I can say this is 12 into 60 or 720 hours. Let's substitute here. So 1 upon 720, this becomes 80 into 720 kilometer per hour square, whatever this calculation is, right? Okay, so this is how you can actually calculate the acceleration. Okay. Sure. So let's move to the next one. So this is the whole concepts of the today's session. Let's try to solve some questions. The first question is differentiate between distance and displacement. Right? We already have seen. We also solved some problems on distance and displacement. Right? So what is the distance? It is the actual path covered. It is also called as path length. We can say. What is displacement? Shortest distance between initial point and final point. We know that. Then distance will always be positive. And displacement could be positive, distance could be negative, distance could be negative. Zero also, right? We have also seen that part. Then distance has the distance is always greater than or equal to displacement, you can say. Right? Distance will always be greater. Displacement could be less than distance, or we can say it could be equal to distance also, right? So in the first case, if you do remember, let's this one. Where you can see in this case, we talked home to school, right? So it is, we are going in the straight line. We are not changing direction. In that case, remember, distance was also 2 kilometers, displacement is also 2 kilometers. But when we change the direction, distance becomes 4 and the displacement becomes 0, right? So displacement could be less than distance or equal to distance, but displacement can never be greater than distance. That also, when of the differentiation, we can do that. Okay, so this is about the distance. Let's take and let's see the another question. For uniform motion in straight line, uniform motion means you are going with the exact very same field, same speed, we can say. Let's say average velocity, right? So 40 kilometer per hour, you are going with the 40 kilometer per hour. So can we say average velocity is equal to 0? No, it is 40. No? So this is wrong. Average acceleration is non-zero. Average non-zero means what? You're giving some acceleration on the bike, right? Now, if the speed is constant, uniform motion means what? Uniform motion means constant speed. So if the speed is constant for the bike, will he give the acceleration? Obviously not. No? So it will be 0. They are saying non-zero, so this is also wrong. Then instantaneous velocity is 0. Right? Instantaneous velocity also is not 0. Speedometer is showing. Displacement is 0. This is also wrong actually. Right? So we have to change one option. Consider, let's say this. Let's change this one to non-zero. Non-zero. Okay. Instantaneous velocity is non-zero. Then we can say yes. C option is correct. Okay. Good. Then displacement can have positive, negative, 0. Yes, it can have all the values. It is very simple theoretical question. Very simple. Okay. So this is the whole chapter, you can say, about the motion and time. This is the introductory part. In next session, we are going to discuss the kinematic equations. What is the initial velocity, final velocity, how to calculate the velocity using the acceleration and etc. Okay. So anyway, today we'll stop here. If you do have any queries, please put them in forum so I can answer them as soon as possible. Okay. So we'll stop here. Thank you very much. Have a nice day.